Hello, this is Henry Halliday, and I'm here to introduce podcast number 3. And this time we're going to be talking about technology revisited with respect to industry and the medical fields. First of all, for manufacturing, technology has been evolving now for many years, but lately it seems that industry has to, as it tries to compete and gain new customers on a yearly basis. Adapting to survive, IoT, wireless, G5, and global competition is extending the range of vehicle-to-vehicle and machine-to-machine communications. And most manufacturers now are trying to respond to just-in-time manufacturing, employing exoskeletons to help worker safety, and expand the workforce by providing physical aids in the help of robotics. Many businesses now are finding they need to think of a modular approach to giving them more flexibility in the designs online, and 3D printing to fill in some of the blanks to reduce the time it takes to get parts and install them into their production lines. And of course, using the cloud has become very important in terms of overall inventory control, keeping track of how their suppliers are doing, and also the analytics to determine are these the best processes and the best way to keep up their production and not end up in significant delays. The use of IoT and AI is becoming more important as they try to make sure that they predict potential breakdowns of tools, especially in robotics, that are now such a key element of their manufacturing process, and they need to worry about adapting the inventory control, the pricing, and the manufacturing process to keep as continuous a process as they can, and yet evolving as technology seems to dictate. The use of modeling has always been important, but a lot of their physical sculpting of designs has been replaced by centralized data, common database, and adaptive engineering that allows them to use 3D designs to really look at the virtual aspect of their manufacturing process and new designs. The use of augmented reality is starting to play a role in the way automotive manufacturers and other fields are perceiving approaches that they don't have to build physical models, but do them in virtual reality and introduce these processes in a real-world interaction through simulations of taking a new design and applying it into a virtual reality on-the-road experience to see how does it work out. The use of robotics and cobots, which is a cooperative robot, into production lines is becoming a very significant interaction where they can try to take into account the fact they do need people in their process to, one, make sure that the interaction between the robots and the physical parts are taking place in a way that they'd like to see that done. Also, as a backup in quality control, where a redundant robot can spot things, but if they're slightly out of kilter, then it's useful to have a person to note that and make corrections real time. The use of the cloud has increased the visibility that manufacturers have of all of their parts and materials tracking, for use of remote sensing and diagnostics of how a production line is coming, and also to predict failures of those most likely parts that are used in the manufacturing process, and try to make sure that a maintenance process is established whereby they can make sure they minimize downtime. For transportation, people have reacted a little bit to the driverless concept, and it's not always in the positive sense with respect to making sure that we take into account vehicle-to-vehicle communications in the future. And secondly, what do you do if older cars, which are still on the road, don't have vehicle-to-vehicle communications? How do you anticipate what their actions are likely to be, which are still real people at the role? For aerospace, we've seen the manufacturing of many different types of UAVs for a variety of new processes, which includes farming, conservation, search and rescue, and hazardous tasks that unmanned vehicles and robotics are playing a significant role now, and it will expand significantly in the future. For space, we have private ventures versus the military, which are somewhat in competition because the cost to do hardware is so expensive, and also the potential of human risk is increased unless there's some overall guidance. Part of this has to do with experience versus innovation, taking into account what men have learned through their space experience, plus new and innovative 3D printed aspects, and how do you incorporate robotics into the space environment and yet keep the cost low. Exoskeletons are emerging as another way to help people handle tasks which it thought was only robotics themselves alone could handle, but now we use the advantage of the leverage that exoskeletons provide, and yet we still have the human being behind the thought process and learning to expand the heavy work levied and improve overall productivity. Vision-guided robotics and robots have now taken a different turn, where they're trying to use arbitrary service orientation with respect to how do they keep track of parts and make sure that, especially if they're going to be mating or trying to do sorting or racking and stacking, what the right concepts are and how we keep track of things which look kind of uniform no matter how you view them, but do have distinguishing characteristics, and according those into the manufacturing process. Lighting and use of different sensors is becoming important in terms of, one, improving quality control, and two, expediting the manufacturing process so that we have attention to details that may have not been thought of before, and also key features that determine one part from another. The orientation of items for racking and stacking, whether it's binning into small parts into containers, or stacking boxes which look the same into pallets where they can be easily moved and directed to the right place for either delivery or production. Finally, we have the integration of visual, infrared, and X-ray processes to help in the orientation of parts and assure a good quality in a production line where a number of significant parts are integrated into a total structure. And this has to do also with the fact that most of the bulk processes which ship many parts to different locations are put on pallets, and these pallets have to have items stacked on them where they can be inventoried and also directed to the proper delivery point. So they need some way of distinguishing whether it's through a package ID symbol on them, or they also could be in a box ID. And so some thought has to be given to that so they can efficiently move packages in line. Maintenance is an increasing factor from a competitive standpoint, where you can't afford downtime or redundant lines, so that it becomes an important aspect of cloud computing, where massive supercomputers can be employed to try and keep track of parts, distributions, and integration of products using their single database, where everything can be cross-correlated through AI, artificial intelligence, and response time, which is becoming very important if you're going to try to make sure that everything comes together at the right time. New sensors are being installed and need to be tracked, especially in the use of cloud computing and intercommunication, where combined visual, acoustic, thermal, and other sensors are integrated into a common environment where the right features for failure prediction and for the proper integration can be tracked. Cobots are becoming an important aspect of maintenance, where some need for tracking how things are performing, and a production line is becoming an important factor of integrating different aspects in the cloud rather than keeping it local to a common workstation. From a safety standpoint, in making sure that people are not in the way or can be hurt by robots. From a safety standpoint, robots are cobots, cooperative robots. Interacting with humans becomes more important if we're worried about not interfering with another, and how you keep track of whether or not either one is doing the right job. So we're going to see a lot more discussion of how do we interact in a viable and safe way as we integrate more and more robots in our production environments. And the use of both two-dimensional and three-dimensional vision is going to be an increasing area of importance, especially in the area of automation for driverless cars, where we try to simulate in an external environment to new additions in terms of how we add sensors to cars, how cars are intercommunicating, or in the case of cars which are not intercommunicating directly with each other, but try to interpolate what cars without the latest features are going to be on the road and interacting with everybody else. So there's a lot of codependence in vehicles which are traveling not only city streets but highways, of mixing smart cars with not so smart cars, and what kind of actions are taken to try and avoid some of the serious accidents we see on the road, where a driver loses control, and what does all the rest of the vehicles do to try and make sure they're not part of the accident that could take place otherwise without predictive actions. So we're seeing in all sorts of industry the increased use of robotics, both in themselves and cobots, which interact with humans. And the key thing here is that the number of devices, call it robotics, that are being offered throughout the world is right now not dominated by the United States, but by China. They have almost a 2-to-1 advantage over producing lower cost robotics than does the United States. And so this is going to be a major issue of technology as we go forward. How do we maintain these foreign generated systems and keep our intellectual property separate from theirs when they're part of our environment? So it's going to be interesting to see how this interacts long term. Now I'd like to move on to the medical field, where we first want to talk a little bit about hospitals. Here there's another significant change in the way that hospitals are very intensive human interaction with humans, but there's been an increasing amount of use of, again, cobots as cooperative robotics to try and help medical profession and nursing in terms of how do we better make use of people and key tasks versus just routine maintenance of the patients. And so there's a lot of experimentation going on now on what kind of action could be used to help the people's side of things and yet not have them interfere with the important tasks that nurses and doctors and aides are performing. So we're going to see a lot of new sensors and attempt to relegate tasks to robotic interaction, but a lot of that is going to be slow in taking place because of the interaction with professions in medicine and the AMA that can slow the progress, but we again don't want to have anyone harmed or interfered with in key medical tasks. New sensors are helping this with respect to maintaining communication of heart rates, blood pressure, glucose, and other key medical parameters so that these can be remotely looked at. And part of this is going to be involved then with the new communication protocols in G5 with respect to making sure the information is obtained remotely and yet part of a overall scheme of maintaining cross communication between the database predictive process and maintaining a schedule that makes sense with respect to all the patients. The use of DNA has become such a key factor now in the way medicine is evolving in terms of are there predictions that can be used to diagnose things ahead of time? What about what's based on family history? What's evolving in DNA that could affect future health and activity? And providing some more information to the medical field on genetic abnormalities, things which aren't quite the same, but could influence how a person lives and gets along in the world. And the specific direction that can be taken to try and help these, whether it's curing or making changes, are going to be influenced by not only the physics of doing it, but the emotional and personal aspects of looking like we're interfering with the person's right to privacy. Gene splicing and editing is already a controversial aspect of things. We try to regulate things, but what do we do about the rest of the world, which doesn't have necessarily the same fairly rigid structure that we try to take in terms of how we're going to make medical changes? We can't stop them because they're not our purview, but we need to keep track of what's going on and how it influences what goes on within our country. The use of 3D replacement parts is expanding rapidly, but maybe not as rapid as we might like, because the AMA performs their function of having to approve not only the materials but the construction and how it interacts with other body parts, particularly those things which are rigid, like joints and bone replacement, and those that are flexible, like the heart and other organs and vessels and nerves that have to get along with these quote-unquote replacement parts. We're seeing a lot of experimentation, but it's going to take some time for all things to work through the materials and interaction with human parts before we see sort of a mass move to be able to perform anything that's a replacement. Those things which look like they're possible through the new materials and use of microscopic generation of parts to create new parts is starting to show some usefulness, but again, it's too early to be able to say how long is it going to take for some of these to really come in and influence the lives of people. With respect to those things outside the hospital environment itself, remote monitoring is going to increase significantly, especially if we come up with a network that can handle the diverse location of where the sensors are, and two, link up with cloud computing or a place where references between one individual and other individuals and classes of individuals are able to be compared and look for new ways of doing things that still maintains the privacy of the information and yet is able to be part of a collection so that we can predict whether or not it's a individual single interaction with the environment or whether it's a class of problems like diseases that we can try to predict and prevent from influences large collections of people where things are at the moment still out of control because we just don't have the communication to do it or necessarily the budget from a world standpoint. Dental profession is obviously making some significant changes too, especially in the area of 3D imaging and also in 3D printing, where we can help deformities in teeth and mouths and the interaction between processes that help us to better aid in the prevention of tooth decay and deformities, and yet be able to do it in a cost-effective manner. I think one of the important things that's taking place in medicine is the ability to be able to communicate into the home, where people have their own methods and methodologies of sleep, of eating, of exercising, and where mechanical aids are helpful in getting people around. And this really is a service industry where cobots or in-the-home robotics could help, but again, needs a communication where rather we depend on local intelligence, which is built into the robots, to be able to communicate quickly and efficiently with a database which ties together the doctors and the patients, and in a collective sense being able to either predict or modify how we do things in the home. It becomes obviously important that everyone get the right amount of sleep, that gets some exercise, and reduces the areas for stress so that we all can have a long life. With that, I think I'd like to close this down for now, and we'll look forward to podcast 4, which will try to catch up across the board on what's happening in technology and innovations, especially Internet of Things. Thank you.